quadratic functions. This I'm going to go through super quickly because this is something that you should be very comfortable with from previous years. It's just a reminder though that any graph at all can be drawn by choosing values of x, substituting them into any equation you're given, and then plotting, then you're going to find corresponding x of y, and then you plot them as coordinates. Okay, so here's an example. Best way of doing this is to set up a little table of values. So we have our x, we have our y. Now, we have to understand what this little range here means. So this tells us that our x values are going between -3 and 2. Now, you have a choice here. Do you do all of them? So you can have -3, -2, -1, 0, 1, and 2. Okay, you can stick them all in. Or you can choose at least 3 points in between those values. I would suggest always choose the end point. So it will have the -3 and the 2. And choose something in between just so you know what's going on. Now, for some graphs, they're not what you're quite used to. So most of the graphs you're used to up until this point have been straight lines. Agreed? Yeah. So they would have what format? What do we know the format of a straight line graph would be?
Y equals mx.
Nice. Okay. These are obviously not that format because I can see there's an x squared in here. Okay. So we're going to talk more about that in a second. But if you're not sure what it looks like, then you're going to need to make sure you're plotting more points. Now, the other thing that you have, that the part of the reason that we're getting you to have them now before you go into IB is to practice using them, is that you have graphical calculators. Okay, not everyone doing their GCSEs have graphical calculators. You're allowed to use them, but not everyone has them. Now, because we have them, a good idea is if you're asked to plot something, you'll probably be asked to complete a table of values like this anyway, but you can stick it into your calculator to have a look at, to see what it should look like. Okay, so when you've got your points and you've plotted them, you just double check to see if you've done it correctly. All right, so let's go back to this then. If we were substituting values in, how am I going to know what to stick in here? Well, I'm going to substitute this value here any place of the x. So I would have -3 squared plus -3 plus 2. Notice I put my value into a bracket to make sure that I'm not getting confused when I'm squaring those values. You can then just chuck that in your calc. So what's -3, or tell me what they are. What's -3 squared? Plus -3 plus 2, 8. Okay? We then stick -2 into there. -2 squared. You're doing it, but I'm doing what? No, so you may get away with doing just a couple, especially if it's a straight line. The fact that these are not straight lines probably indicates you're going to probably need to do a few extra. Okay. And what's -2 squared?
4.
Plus -2?
2.
Plus 2?
4.
What's -1 squared?
1.
Plus -1?
0.
Plus 2? 0 squared?
0.
Plus 0?
0.
Plus 2?
0.
1 squared?
1.
Plus 1?
2.
Plus 2?
4.
2 squared?
4.
Plus 2?
6.
Plus 2?
8.
Okay? So there are our coordinates. Now you will notice on the next page and the following pages are lots of set of axes for you. Okay? So you're going to then plot those as coordinates. Now you are going to fill in the tables and you're going to choose a sensible scale. And often in an exam they will give you the scale already drawn. So they will have these numbered. Okay? But if they haven't, you have to be big girls and decide what numbers you're going to use. Now, there's no good putting up your hands and say, what shall I use? What scale shall I use? What should I write here? How am I going to do this? You are very, very intelligent ladies. You can work it out. you can see that your x values have to go at some point at least between -3 and 2. Okay, you can see that your y values don't go to the negatives at all, so secretly you wouldn't even need the bottom quadrant like this one, but you do have to go up to at least 8. Okay, so you're going to plot those points, but you're also going to have your calculator with you to practice using it, and you're going to enter this function to see what it looks like before you join up the points. Okay, because I don't want you to just literally join them up. Now, when you're joining up points when it's not a straight line, you must not use a ruler. Okay, so you need to use a pen. But I think I've talked to you about this before. I don't want to see anything like, oh, that's beautiful. And there's 16 lines there and we've got no idea what you're trying to do. Okay? If you're joining up 2 points, then you join up the 2 points. Okay? None of this artistic, beautiful shading. Alright, so I'm going to leave you time to fill in little tables for these ones. Okay? And draw those graphs. I'm hoping it's not going to take you more than like 20 minutes.
Wait, how do you draw a graph?
Plot points.
Oh, okay. Wait, also does x and y have to go up in the same intervals? Like
No, so you can have a different scale on your x axis, your y
You
axis.
should do like a squiggly line though. You should do that in science. Okay, would you look at that? No,
Okay?
you don't go over the same.
This is the recording though. But Emma, you can't, so for here, you can't have 1, 2, 3, 4, 5, 6. Like, you can't do that.
No, I mean evenly spaced.
Yes. But when you say that, like, obvious, some people not so much. Okay? So you've got to make sure that
Pretty
they,
strong.
you've got to make sure they're even. Now, I would also suggest always when you're labeling, start at the middle, go to the right with your positives, then go to the left with your negatives. Because some people will leave 1 gap for a number and then 2 for everything else, and it goes a bit pear-shaped if that happens. Okay? So I'm going to leave you to practice. All right, so we're going to use our calculators to check that we've done these graphs correctly. So this is our initial calculator screen, I'm guessing, yes? And you can see that you can scroll down to the graph if you wish. There's several other ways of doing it, but that's one of them. Okay, so I'm going to hit enter, and you should get this screen here. Okay? Now, at the top it should say F1 brackets X equals. So it's in functional format.
Mine doesn't. Where does it say that? Mine's like that. Press tab.
Okay, so you can either press tab.
Where's tab?
Here, I'm trying to show you on the screen at the same time. So can you not see this? Jersey, maybe can you turn the light off?
Oh, yes.
Sorry. Does that help or not?
Yeah.
All right, so girls, please. Once we've got this, we need to enter it. So if you can see at the bottom, it's QWERTY. Well, it's not QWERTY keyboard. There's all letters. Now the X, Y, and Z are in white because you're going to use them the most. So we're going to try and input. What's the first one? X. What's the first one?
X squared plus X plus 2.
X squared. So we're going to use the square button. Plus X plus 2. So we're just going to type that in where it says function. Okay, so as I say, your x's are on the bottom, the x, y, and z are in white. The squared is obviously the squared sign. And then when you hit enter, it will normally graph it for you. Now, if there's any reason you cannot see the graph, it may mean that it's out of, it's off a different scale. Because I can see that my scale here goes from 7.39 down to negative 7.39, and so on and so forth. Shh, and if you hit menu, when you're in this, you can look, if you want to change the axes, you can zoom in and out for a start. So window zoom. Okay, you can change whether you see the axes or not. You can see the grid lines or not. So if you prefer to have actual grid lines, you can see them. What else can we do? I think settings should be a general answer that we shouldn't need to worry about that. Okay, so that's our graph. So we can see that it's what we call a parabola. Lovely jubbly. Now, if we want to do something else, we hit menu and we go to graph entry. Okay, and you can then enter a second graph. Okay, so this one would, what's the next one? X cubed. Now, see this hat? That tells you it's a different power. So x cubed plus 3x.
Wait, how do you enter a different one?
Oh, you can press menu. Menu and graph entry. You're just entering a function. Yeah. Or you can delete everything and start all over again. It's up to you. Pardon? Who said what?
Can I have some juice?
Sure.
I thought you were like...
Something else.
I
Okay, so let's see if she's got.
Sorry,
Just see.
yeah, we have one. Oh my god,
Maybe switch to Jen so she can play one now. Which is what I mean.
Oh, yeah.
You can. All right, girls. Oh my gosh, we've just recorded that whole thing. Right, so if I want to enter the x cubed one again, sorry, I'm entering the function, so we've got x to the power 3. Now, we need to move across, otherwise it's going to not enter it correctly, plus 3x. Okay, press enter, and we can see it looks like that. Yeah.
How does it get out of the split with the...
Alright, so 1 second, let me try and show people that. Now, so here's looking at the screen. Now, I did show people one method a while ago, you may or may not have remembered. If you press the menu, and if you see where it says table, you can, if you hit split screen table, what you can have is the graph on the left and then the table on the right. Now, this table on the right actually tells you the values that should go into your table. Okay, so for integers, but these are your x values, they give you the values that should go into your y. So if you're asked to complete a table, you can just enter the function and see which values they are here. You can slide it up and down to see different things. If you no longer want that as a split table, you go to menu, table, remove table. Okay, and then that will go back to your full screen. Okay?
Can we do the last?
So I'm going to leave you to practice, play around with the rest of that, just for 5 minutes, okay?
It's lower now.
Okay, so we've talked about being able to draw any kind of graph you want, right? And there are certain kinds of functions, certain kinds of graphs that you are expected to recognize without needing the calculator to remember. Okay, a quadratic graph is one of those very, very, very common graphs that you really do need to know quite a lot of information about. Okay, so the graph of a quadratic function is called a parabola. Okay, so it has a fancy name, it's called a parabola. The highest power of x is 2, so you're going to see an x squared in there somewhere, no more than x squared. And remember our general form of ax squared plus bx plus c equals 0. We all remember this format? Yes? What did we use our values of a, b, and c to do? Do you remember? In the quadratic formula. What did the quadratic formula find for us?
Squared y-intercept.
Almost. Not y-intercept. It found us the x-intercepts, because if we were solving that this equation was equal to 0, that means that's where it crosses the x-axis.
So this equation finds an
x-intercept.
So it finds x-intercepts?
Well, if something is in this format, we can use the quadratic formula to find the x-intercept, yes. Okay, we can equally factorize it to do that as well.
So this itself doesn't actually find x?
No, that's just if it's in this format, we can do something with it. Okay? Now, any graph, any parabola, is going to be one of two shapes. If the x squared value is positive, then it is looking like this. Okay? I like to say that that's positively happy. It looks like a smiling face. Okay, so if the value in front of the x squared is positive, then it's going to be positively happy. If we were trying to identify, this point here is known as the vertex. And in this case, that would be a minimum point, which makes sense because it goes down and that's the lowest place that we can see it goes to. Okay, so that's the vertex. Sure. Okay, so that's the vertex, and it's known as a minimum point for a positively happy parabola.
So the vertex is in the minimum.
In that instance, yes.
Also, so positively, did you fill in any words or no?
Nope.
Also known as a minimum. So the vertex is also known as a minimum.
For that
So could I write vertex also?
Sure. If x squared is negative, what do you think it looks like? A sad face. Okay, it's negatively sad.
How do you sad?
Wait, but it's negative and negative.
If you multiply together, all looks good and
Negative makes basically, you're happy.
positively sad. It should say positively sad. Alright,
Negatively sad.
now, this is my way of helping you remember. If you're going to ignore it, you can ignore it. If you want to pick holes in it, but don't tell me about it. Okay? I'm trying to help you. You can choose whether you take it on board or you ignore it. Fair enough?
Yes.
Yeah? Great. Now, this here would also be a vertex. So Emma, this would also be a vertex. But this time for a negative parabola, it would be a maximum point. Okay? So the highest or lowest point they're both called vertices or vertex. And for this one, it'd be a minimum, this would be a maximum. Okay, so as I've said at the bottom here, the maximum minimum point of parabola is called a vertex. So it does say that on there. So that's the basic shape of them. Something else you may like to know about them is that they are symmetrical. Okay, so they are symmetrical graphs. Oh, here. Okay, so when you're drawing them or sketching them, you wouldn't ever sketch something that looks like this. You would try and make sure that this is symmetrical. Now, it's also symmetrical about its vertex, which means that if you were to draw in a line of symmetry, these two halves would have to be exactly the same, or as much as possible when you're sketching. Okay? Now, as I said before, we can draw any parabola by choosing values and putting them into the equation. In some cases, it's going to be faster though to sketch them by recognizing features of the given equation. It's likely to involve factorizing the equation first if it's been given to you in a different format. So, we're going to use this example here to have a practice with. So, x squared minus 3x minus 4. If we're going to try and find our x-intercepts, we would say that the y value was 0. So we would say 0 equals x squared minus 3x minus 4. If it's equal to 0, it means that we can solve this equation to find where it crosses the x-axis. The easiest way to do this, if you recall, is to try and factorize it. If you are not great at factorizing, you could use the quadratic formula that we just discussed. Remembering that quadratic formula, your calculator does that for you. Okay? That's essentially your only way of doing it. So, can we factorize this? How do we factorize a quadratic? Is a review for you. How do we factorize a quadratic?
So we have multiplies to get minus 4 and adds to get minus 3.
Okay.
So it's opposite. Multiplies to get minus 4 and adds to get minus 3.
That's right. But what's it going to look like when it's factorized? Two brackets. Nice. Two sets of brackets. And if it's an x squared at the front, it's just an x at the front. Yes? And as Emma said, we're trying to find two values that multiply to give negative 4 and add to give negative 3. What's that going to be?
Minus, I don't know. No? No, minus 4. Wait,
Minus 4 and
minus
1.
4.
Okay, negative 4 and positive 1. Because negative 4 multiplied by 1 gives us negative 4, and negative 4 plus 1 is negative 3. Okay? Now, remember, this is the final step of this. We've factorized it using our values. What does that mean that it crosses the axis at? Which values does it cross it at? Careful.
Negative 1. Negative positive. Isn't it
Yeah,
4
negative. It's just it's the opposite value. So if this was an x minus 4, we know that x is 4 is one of the values. And if x plus 1, it means that negative 1 would be one of the values.
So x is 4.
The calculator gave it x.
Pardon?
Calculator gave that answer.
The calculator gives the answer. Perfect. Alright, so that means that I know it's going to cross the x-axis at those values. So if I was to try and sketch this, and in some cases they may be looking for these things when they're asking you to sketch it, I would label my graph. Should we go up in 1s or 2 squares?
1,
2.
I'm going to go up in 2, so I'm going to say 1. Oh dear. Oh, this has really gone out of sync. Okay,
1 for every 2.
I did 2 squares represents 1 unit. So I know it's going to cross at negative 1 or positive 4. So I'm going to, here, at negative 1 and positive 4. Oh. Okay, so I'm going to cross my x-axis there. Okay, so I'm crossing my x-axis at those 2 points. Okay, I can't draw a parabola just for that information. Okay, so let's look at some more stuff that we can use. Now, the point at which the graph crosses the y-axis, or in other words, the y-intercept, can be found by substituting the value of x as 0 into the equation. Okay, so when x is 0, y is going to be 0 squared plus, it's minus 3 lots of 0 minus 4. Okay? I'm substituting the value of 0 in place of x. A bit confused,
0
I know.
squared. Oh yeah, minus 3, 0.
Wouldn't it just be minus 3?
Wait, minus 3 to the power of 0?
No,
No,
it's just the board. The board's just out. So that gives me a value of negative 4. So I now know that when x is 0, it crosses the y-axis at negative 4. I'm just going to go down in 1 now.
So x equals 0, y
Or should I go 2 squares anyway? I'll go 2 squares. So minus 1, minus 2, minus 3, minus 4, minus 5. So I'm going to know it goes through this point here. Okay, so I've got my 2 x-intercepts, I know my y-intercept. Let's finish this off next lesson. I think it's probably the easiest thing. So those of you that are not here, you're just going to have to catch up what you missed. When's the next lesson? Okay, next lesson is Thursday. Okay, right, so you need to